Hello, and welcome to my lecture on vertical and horizontal asymptotes. We'll go ahead and get started right away here. And so let's imagine that we're taking a limit of a function f of x as x approaches 2 from the left. If that limit's equal to negative infinity, that tells us that we have a vertical asymptote at that location. So it means that there's a vertical asymptote heading down on the left side of the vertical line x equals 2. So let's take a look at like a drawing of that. So x equals 2. If the function's coming in from the left-hand side, it means it's coming from over here, and it approaches a vertical asymptote on the left-hand side, and it's heading down because it's going to negative infinity. Next, basically the same idea going on here, except for this time, we're approaching x coming in from the right. So as the function approaches x equals 2 from the right, the function is heading up towards positive infinity. So that gives us a vertical asymptote heading up on the right-hand side of the vertical line x equals 2. All right, let's take a look at a horizontal asymptote. So in this case, notice the limit is now going as x approaches infinity, and that's equal to 3. So what that would mean, as far as the drawing goes, as the function goes further and further to the right, then the function gets closer and closer to the line x equals 3. Now what we don't know if it comes from below or from above. It wouldn't do both because then it wouldn't be a function. But it either comes from above or below and heads closer and closer to the horizontal line x equals 3 as x gets larger and larger. All right, so as I said, this means that there's a horizontal asymptote heading to the right, so right because it's positive infinity, and getting closer and closer to the horizontal line y equals 3. Okay, let's take a look at a graphing example here. Now this is a type of problem that I like to give to get students to really get a feel for what the function would behave like given some various limits or values of the function. One of the first things I like to do, I scan through and see if there's any points on the graph. So here's a point 0, 1. So if we go to that point, 0, 1, let's change to the actual graphing over here with a different color. So that's a point on the graph right there. Now I look at this and I realize this is at negative 2, 1, 1, and positive infinity. So it's generally going from the left to the right with the exception of this one, which was we've already taken care of. So let's say as x gets closer and closer to negative 2 from the left, so our original color for our 1, 2, 3, 4, 5. So sorry for the really jagged lines here. So as we're getting closer and closer to x equals negative 2 from the left, the function's getting closer to 3. So right now we're just going to go to 2, 3 and put a hole in the graph right there. And then dropping down to this one. So that basically takes care of this. And the function's approaching there, so coming into here. We don't know if it's coming from above or from below or straight across. But anyway, the function, as it gets closer and closer to x equals negative 2 from the left, the y value is getting closer to 3. And then coming in from the other side, the function is approaching 2. So it's there. And it's coming from the right, so we'll say it goes through that point. It could have gone up and then come back down to this or something, but we'll just go generally over. Now notice I have these both empty. Now this hasn't told me to fill either one of them. You know, it could have said something like f of negative 2 is equal to 3, then we know to fill one or the other. So we can fill one or the other, our choice, but not both, because then it wouldn't be a function. And they did say that this had to be a function. All right, we're going to need some more numbers over here to this side. So now, as x approaches 1 from the left, so that's right here. I'm going to go ahead and do this vertical asymptote. The function is heading towards positive infinity. So we'll have it just go, let's undo that little piece. Let's change that back to the red. Have it go up like that. Slightly different color red this time. And it's heading up towards positive infinity. On the other side, as x approaches 1 from the right, it's also heading towards positive infinity. And then meanwhile, just so we know where we're heading, as x goes to 2, as x goes to infinity, the function is going to -2. So that's going to mean we have a horizontal asymptote. I just changed colors. We have a horizontal asymptote down at x equals -2, and it's just off to the right. Notice I don't draw it all the way over here, because this is telling us about the behaviors of the function as it gets close to infinity. It says nothing about the behavior of the function when you're close to the y-axis. So if we go from here, excuse me, I was trying to do these colors in red. So in red, so it goes basically like that. Okay? And you can see that we've met every requirement. We'll come over here, maybe have that goes an arrow. So each one of these meets a certain requirement. This spot is we're coming in from the left. We're approaching, the function's approaching 3. So up there at 3. And coming from the right, the function's approaching 2. So coming in right here. So that takes care of this piece and this piece. F of 0 is 1, so that's over here. We've got that in. As we approach 1 from the left, the function's going up to positive infinity, so it's right there. And as we approach 1 from the right, the function's also going to positive infinity. And as the function approaches, as x approaches infinity, which is off to the right, the function's approaching -2. Okay, so that's an example of a type of problem I'd like to have you be able to work. Okay, let's go to the next example. All right, so the next example, if we're asked to find the vertical and horizontal asymptotes for a function, so here's an example of how we would do that. So first of all, to find the vertical asymptotes, we need to write this in factored form. So I'm going to write this as, well, of course the top doesn't factor because that's a sum of 2 squares. The bottom can be written as x minus 2 times x plus 2. Okay, so none of those cancel out with anything on the top, so both of these spots give us asymptotes. So we have vertical asymptotes at x equals 2 and x equals -2. All right, so now let's take a look at the horizontal asymptotes. Now the horizontal asymptotes, to find those, you need to take the limit as x approaches infinity of the function. Well, as x gets really, really large, this value and this value become almost meaningless. So this ends up being equal to the limit as x approaches infinity of x squared over x squared, which is equal to 1. So we can tell that we have a horizontal asymptote at y equal to 1. And that would be true whether we're going to positive infinity or negative infinity. Okay. Now, let's look at our next example. Now, in this case, we're just asked to find the horizontal asymptotes. And I wanted to show you how this will vary based on the degree of the function. So notice in this case, both the numerator and the denominator have the same degree. So doing the same thing as before, we can look at just the highest degree of each piece. So that means that this would be 3x squared over 5x squared. So we have a horizontal asymptote at x equals 3/5. And that's actually on the left-hand side of the graph and the right-hand side of the graph, because it doesn't matter whether we're going to positive or negative infinity, we get the same. All right, in this case, notice the degree of the numerator is 1 and the degree of the denominator is 2. So again, once we can ignore all of the lesser degree parts of the function, the end behavior of the numerator is 5x, the end behavior of the denominator is 7x squared. So this thing behaves as 5x over 7x squared. And you can see that the denominator is going to get larger faster because we have a squared term there. So basically, this is heading towards 0. So we have a horizontal asymptote at x equals 0. All right, one more example here. In this case, the numerator is 2 degrees higher than the denominator. So that means the numerator is going to get larger much faster. Again, ignoring all the lesser degrees, this thing ends up being the limit of 5x cubed over 4x, which would then reduce to be the limit of 5x squared over 4. And you can see that the numerator is growing way faster than the denominator. So we actually end up where this is approaching infinity. So we have no horizontal asymptotes. Okay. The one other thing I haven't addressed in this, but I'll at least talk about it for a moment, is that if you have the numerator just 1 degree higher than the denominator, then you actually end up with a slant asymptote, and you have to do long division to find that slant asymptote. All right, that is the completion of this particular video. If you have any questions, be sure to send me an email or ask me questions in class. Thanks so much for listening.